Hello everyone, today we will discuss about the force, composition of the force and resolution of the force. Force is defined as a vector physical quantity, so it has the magnitude, direction and as well as follow the law of the parallelogram. Here you can see that if a body is in rest, then after applying force you know that it can be in the motion. But if a body is already in motion, then it is also possible that after applying a force we can bring it into rest. Here you can see in this diagram that a body is displaced through a distance A to B by applying a force in the direction of theta to the horizontal direction. Mathematically, the force is defined as mass into acceleration, and the dimension of the force is equal to ml t to the power minus 2. The unit of the force is kilogram meter per second square. It is mks unit, and if mass is 1 kilogram and acceleration is 1 meter per second square, then the force will be equal to 1 kilogram meter per second square, and it is equal to 1 Newton also. So 1 Newton can be written as equal to 1 kilogram meter per second square. Now we will discuss about the composition of the forces. Now here you can see this is a body, and the two forces F1 and F2 of different magnitude are acting on different direction on this body. Let us say that O is the action point of the two forces, and the angle between the two forces is theta. So we can have a resultant force which will have the same effect at point O as the effect of the forces F1 and F2 combinedly. So from the law of the parallelogram, if F1 and F2 represents the two adjacent sides of the parallelogram, then the resultant force will be in the direction of the diagonal of the parallelogram. So we can write the resultant of the force F1 and F2 as R is equal to root F1 square plus F2 square plus 2F1 F2 cos theta. Here you can see that if theta is 0 and F1 is 3 Newton and F2 is 5 Newton, and these two forces are acting in the same direction, because here theta is 0, so our resultant force will be 3 plus 5, that will be equal to 8 Newton. So this is called as the composition of the forces. Means at point O, when your theta is 0, the F1 F2 will have the same effect as the resultant force R, or the resultant force R will have the same effect at point O as the forces F1 and F2 when these are acting in the same direction at point O on the body. Now we will define the resolution of the force. Here let us say that F is a force which is acting in a particular direction. Let us say it is making an angle of theta with the x-axis. Then we can resolve this force F into two parts. One will be along the x-axis and one will be along the y-axis. So these are called as the resolved part of the force F. The resultant of the force along the x-axis and along the y-axis will have the same effect as the force F. So we can write the x component of the force F is equal to Fx, and that will be equal to F cos theta. Similarly, y component of the force can be written as Fy, and that will be equal to F sin theta. So here we can find the resultant force, that will be equal to root Fx square plus Fy square. So here we can see that the combined effect of the x component of the force and the y component of the force will have the same effect as the resultant force F. Now here you can see that, let us say F is equal to 10 Newton and theta is here 45 degree. So Fx here will be 10 cos 45, we can write it as 10 by root 2. Similarly Fy will be equal to 10 sin 45, so it can be written as 10 by root 2. Now if we find the resultant of the force Fx and Fy, then it can be written as root Fx square plus Fy square, and that will be equal to 10 Newton. Thus we can say that the force has been divided or resoluted into two components, one along the x-axis and one along the y-axis, and their resultant will have the same effect as the magnitude of the force. Thank you.